My name is Jason, and I do things security-wise with a company called Cequence Security. They fly me around and I speak at all these conferences. I recently spoke in Riyadh last week. I speak all over the place. I do a lot of OWASP events and I teach for OWASP. I've been doing this for about 24 years. You give me URLs, I give you error messages. That's how this works. And then you go fix those error messages. A few years ago, I bought a new garage door opener for my garage, and it didn't have a button. You know how you used to have a button and you'd push it and your garage would open? And I got this garage door opener and I said, there's no remotes in here. And they said, ha, there's an app. Use the app on your phone and you can open your garage. And I went, all right, I guess I can do that. And I opened the garage with the app on my phone, proxied through my laptop. And then I opened the door with my laptop. And then I called a friend of mine and I said, didn't you just buy one of these? And he said, yeah, he lives about 2,000 miles away. I said, can you read me the number off the back of your garage door opener? And he goes, sure. And he read it to me. And I said, is your door opening? Yes. Excellent. I was just a few lines of Python away from opening all the doors. They had an insecure direct object reference problem. I do a lot with GraphQL, and I can't stand here in Australia and not give a shout out to the Asset Note guys and the Kite Runner folks. Really great, amazing stuff. I'll actually put up a word list that I think is a little bit more accurate than theirs. But I collect GraphQL endpoints, API, open API files, these sorts of things. I build tools and teach. I worked for OAuth Summer of Code last year. It was the most popular class. I taught people how to tear apart APK files for Android apps, pull API endpoints out of them, and then go attack those API endpoints. So it's a really interesting thing. This is my LinkedIn page. I don't know why we've all moved to QR codes, but it seems easier. You'll see a whole bunch of them later. If you guys want to connect with me on LinkedIn, that'd be great. If you don't want to, you don't have to. So what is the problem? Well, we're starting to see more and more organizations get attacked through their API platform. There's a lot of different reasons for this. It used to be we instrumented everybody that came in the front door. You go through the web app, right? You go through our website. That means I can run JavaScript on your machine unless you're running NoScript or something. I can see a lot more about that end user. APIs are meant for computer-to-computer communication. They're not meant for an end user to be interacting with it. And then we went, well, wait, I can make a mobile app and it'll just do the same thing that a web app will, and we'll just call these same endpoints and we'll make it all easier. And then GraphQL came along and we're starting to see APIs are everywhere. But we're also seeing that the indicators of compromise in these APIs are happening in ways that seem a little different, right? Optus, you guys are all quite aware that Optus had a problem, right? What was their indicator? It's the Brian Krebs notification, right? Where you get somebody calling you saying, guys, here's 3 million accounts that we have a bunch of information for. The indicators there were after breach, right? And so we're going to talk about some kinds of indicators that are out there. Things like if you work in retail and you use gift cards, does that gift card check endpoint get hit a lot? Well, of course it does. People are checking to see if their gift card has any value on it. What if you're guessing numbers and trying to figure out what gift cards might be out there? Your indicator might just be activity, right? Strange activity it might be, but there it is. So what are we going to talk about today? Well, we're going to talk about what API attacks look like. My company that I work for, this is all we do. We sit in line with APIs and watch the attacks fly in and mitigate them. And so we're going to talk about what are the things that we use as part of this solution. What is an IOC? What really is it, right? What are the common IOCs and APIs? Where can you instrument to find them? What kind of data can you use? And then how do you put this together? So if we look at an API attack, this is usually what happens. And this doesn't really matter what it is. Whether it's a hype sale, where somebody's trying to buy shoes. Shoes is one of those weird things that I have to go protect a lot of and don't understand, right? Why people buy Nike Dunks, I really don't get. Why Yeezys were something that was important, I don't know. Keeps me employed though, as they keep getting attacked to buy the things, right? But what happens in the first phase of this is just simply reconnaissance, just like any attack. I need to see what's there. What can I do? What are the interesting things I might find? What is it that I'm going to be trying in a few minutes when I move on to the next phase, which is testing. And in the testing phase, I'm just going to see, can I get this to work, right? And this is where you spend all your time. Pen testers in the room? There's a few, right? And this is where you spend all your time, right? I wonder, dang. Everybody thinks that you're like in the matrix constantly and it always works, but I've been there. You know, you throw a million things at it and none of them work. And then finally you rip something out, it does. Testing, right? But once you get it figured out, then you move to scripting, right? We're going to start running this thing a little bit harder, and then maybe somebody's going to notice it, right? You get a little loud with what you're doing and they shut you off, then you got to retool, right? And you got to move to the next phase. And this is what happens over and over and over again. And that reconnaissance phase, I've got to figure out where your API endpoints are, right? So anybody that wants to can pull their phone out right now and they can pull out a web browser and they can type api.twitter.com. And they'll end up on the API subdomain for Twitter. If you throw /GraphQL on the end of it, you'll get some error message about a malformed GraphQL request. How hard is that to figure out? Well, Elon said something about a bunch of RPCs failing the other day, and somebody posted back to him, you even understand how GraphQL works? And I went, oh, there's a GraphQL endpoint on that API endpoint, you know, and I just started enumerating through it, and there it is, right? I don't need that. I don't need all these other tools because Elon will just tell me where they are. But the rest of us are going to try to find things, and there's lots of things out there. APK mining is something that I do a lot of, tearing apart Android applications, because it's basically just a zip file, and inside that zip file, there's a couple of different XML files that just point at all of the paths that you might be willing to go after. And so that makes things really easy. But if you're attacking an API endpoint that's maybe east-west traffic, right, isn't north-south traffic, isn't something that's generated by an end user, but is actually coming off of another thing, then maybe we got to look at DNS searches, or we've got to go to tracking pages, right, to figure these things out. My friends and I are starting to do a bunch of research on free food, right? Sign up for the app and you get free French fries at McDonald's. It's an interesting thing. So I had my son sit down with 100 cell phones and create 100 Gmail accounts as part of a class project that I funded, and 100 free French fries, right? That's an easy thing to do. But what happens when it gets a little bit more complicated? What happens if you've got to buy a bunch of things and associate it with all those accounts? Well, then we have to dig into the APIs and look a little bit harder, and cracking will help us with that. It'll help us build config files. So after we get our reconnaissance done, then we have to move into testing. And the IOCs for testing are really hard to see in your app environment. When you start to look at the traffic that's going to come in on this, it's going to look like what we call single request attacks. It comes from one IP address, one user agent, one username per request. So it looks like it's spread all over the world using all these weird different user agents. Each request looks like it's unique, so it's really hard to trend unless you trend all of the data, right? How many data science folks? One. It's the future of cybersecurity for sure. Because looking at this data lets you see things like these single request attacks. But you'll also see stuff like this. Does anybody know what XML-RPC.php is? Anybody here run WordPress? This is the WordPress RPC, defines what RPCs can happen against a WordPress site. If you see somebody trying to go to this endpoint on your APIs, they're running a scanner. It's pretty easy to kick them away, right? Just look for that UA and kick them off. Let's talk about versioning though, right? V1 login versus V2 login, where I recently had a customer that said, we accidentally left our V16 login on and they were on V37 or something. And V16 was standard username, password authentication, and V37 was SAML, right? So I'm bypassing your SAML authentication by using an older endpoint that you forgot to shut off. I'm now going to say something that I'm writing a talk about But this is the most important thing in API security today. If you have API 2, API 3, and API 9 in your environment, you are step functions further down the line to be hacked than anyone else is. We've done analysis on over 1 trillion transactions, several different hacks. This comes from our data, but I also did a birds of a feather talk at RSA conference last year, and I sat with a bunch of banks, and I said, what's it look like when you get attacked? We piled this all together, and we realized if you don't have authentication, you have excessive error messages, and you have endpoints you don't know about, you're doomed, right? And if you look at breaches that maybe have been in the news lately, you'll see a pattern there. So once we get past, we did some recon. Once we get past, we test to make sure that it's work. Now we're going to start firing the tools, right? And if we look at the history over time, command line tools were first. We use curl or something like that, right? To just ping the site or make sure that things are up or I can get to the endpoint. But then we rolled into using tools that were framework attack tools. So it understands I'm going to make a web request, and it understands it's going to get a response back, and I've got to parse data. Maybe you have to point it at the login page. So tools like OpenBullet or Sentry MBA came out. If you're a retailer, you battle these tools all the time. If you're in banks, you probably spend a lot of time with these things. But basically, it's a framework tool. You create a config file, you drop the config file onto the framework, and it'll go get you free pizza from Domino's, right? I use Domino's as the example all the time because if you go to cracking.org, Domino's is the first one that comes up. I don't know if it works here, but in the US it does, right? Scripting, the IOCs on this are going to be volumetric. You're going to see a lot, right? It's going to look like computers coming after you. The robots are really hitting you hard. So you're going to see things like in 40 minutes, 25 million requests when you normally don't have any requests, or your volume is much lower than that as it comes through. We've seen things like 35 or 350,000 account takeover attempts in 25 minutes. That's a slow attack for us. We usually see them much faster than that, right? And now with GraphQL becoming more and more adopted, GraphQL has this really cool feature in it called batching, which lets you put a whole huge pile of requests together as one request. You send in one request. So if you're logging and you look and see what happened when this transpired, you're just going to see one request. But if you open the JSON object in that request, it's going to have all of the stuff inside of it, right? And hopefully it didn't get you a whole bunch back. So you're going to go in there and figure this out and stop them. And then what's going to happen? Well, I'm going to go find a meme generator for retooling and tell you all about what happens when people start to retool, right? So you're going to see this, initially, you're going to see this coming from Amazon, GCP, Oracle Cloud, Google Cloud, right? Cloud services are going to be attacking you. Do your end users typically come from Amazon IP address space? Probably not, right? It might be, depends on your business, but normally it doesn't. So then we got to move into residential proxies, right? We need to reflect this stuff off of residential IP addresses. That way it looks more legitimate, right? So where can I go get a bunch of residential IP addresses? Anybody know? Illuminati changed their name to Bright, but yeah. So there's a whole bunch of these. Anybody know how they get them? How do they get the residential IP addresses? How many of you believe that when you use Starbucks network, you need to turn on a VPN? Or insert whatever free Wi-Fi network here. You have to turn a VPN on to be safe. Those YouTubers will all tell you, NordVPN is the way to go or whatever, right? But you got to pay for all that stuff. What if you want a VPN that's free? I question efficacy here, but okay. So there's a VPN out there if you guys want to look for it. It's the Spanish word for hello. It's Hola VPN. Hola VPN, when you read the terms and conditions, says that you become an endpoint in the Illuminati network. You're now a residential IP address that some botter is going to go use. Now we're only going to use a couple. right? We're only going to be on there for a few transactions, but here I am reflecting IP addresses off of what look like real, legitimate end users in cell phone networks using set-top boxes and that kind of stuff, right? So what's that mean? I got to spend more money. The infrastructure gets more expensive, the better this goes. And so as you see these attackers retool, they're going to retool to more expensive options. They're going to realize that their user agent strings are all 3 months old and they need to update them, right? They're going to realize that these IP addresses are bad. And so you're going to see this. But if you're using behavioral analytics and data science, doing things like what's the first thing this end user did is going to tell you an awful lot, right? Also doing a bunch of analysis on all of the IOCs. So what are the IOCs and APIs? Is it the same as everywhere else? Is it a bit different? Well, we just had the forensics guys up here on stage talking about malware attack and ransomware attacks, but IOCs are just a piece of digital forensics, right? Think about what it is you're logging or what might be inside of your environment that's going to tell me a little bit about what's happening when an attacker attacks your APIs. Just like physical evidence, there's digital clues, and it's going to take you further and further down the line. So what are the common ones? Well, you see them in login endpoints. And here's where behavioral analysis becomes really important. If you have an exposed login endpoint, so if your organization has people log in from outside, and you look at that login endpoint, look at how often someone succeeds in logging in all day, right? So how many successes did we get today? How many failures did we get? And then you sort of set high watermarks in that, and when you start to see that login failure rate climb up, you're under attack for a credential stuck being attacked, right? As that failure rate climbs, you realize somebody's trying to get into that login endpoint. We also see things like user agents, right? Browser make. If you're talking about APIs, it's pretty rare to see somebody with Firefox touching you, right? Normally, it's your app. If you work with your development team and have them set versioning inside of the app user agent string, you can use that to track which users are touching your endpoints, right? It makes it nice and simple. A lot of this comes from doing direct analysis, but what we like to do is to do some data science and understand where the data pivots might unmask things that are happening. So if you look at things like login request for user, Bob comes from France, and then it comes from China. Bob probably didn't go from China to France or France to China in the middle of this transaction, right? So just simply understanding the IP addresses that have come in and doing a pivot off the user and the IP addresses is going to help you. Similarly, user agents, things like volume, right? Behavioral analytics is going to do a lot. I took the build out of the slide. It came back. So what does it look like when somebody's doing things like scraping, right? Is scraping illegal here? I'm not up on laws in Australia. Is it legal to scrape websites here? Probably. Okay. It's legal in the US. You're allowed to do it. You can stop somebody from doing it, but it's legal for them to do it. So in the beginning, right, wget style scraping would be something that somebody would do. They'd fire a script at you and they would pull down every element of the page, right, kind of indiscriminately. But then we start to see things like, well, if they're scraping you like that, they're noisy. They're easy to see. You can shut them right off. So then they move, right? We start to use things like inexpensive IPs. Somebody figures out that they can get a proxy list, right, and start running through that. As we move down through this, though, you're going to see things like single request attacks, really high volume, rotating the user agent strings as well as the IP addresses, and they don't look like anything is going on except there's a huge amount of volume in the requests that are coming through. I work with a lot of organizations that do things like they resell cars, right? And it's If I sell the car, I get the commission. So if I go scrape someone else's website that's reselling a car and I list it and I sell the car, I win, right? We work with a lot of organizations that are kind of underneath that. And it's really fun to watch. You take a picture of one of the cars that they're trying to sell and pull all the watermarks off of it. And this picture has gone to like 27 different sites. And everybody throws their watermark on top of the old watermark to say it's theirs only, all right? This is a really weird economic thing that happens, but scraping still exists today. People are still doing it. So in account takeover, though, you see things a little bit more sophisticated. There's a little less rattling the doors. What happens in the attack setup for an account takeover? I've got a list of usernames and passwords, or list of usernames that I want to go develop password lists off of, and then take the accounts over. You're going to see they're going to need a bunch of this stuff. They're going to do a bunch of these single initial requests, but eventually they need to get through the list, right? If I have your username, but I don't really know what your password is, how many combinations is that? It's a lot, right? And it's going to be a big password list unless I dump the database and I actually have your username and password. If I just know your username, it's a long time to figure this out. I recently did a responsible disclosure with a camera company. I've got a greenhouse out back in behind my house I grow vegetables in. And I came out one day and something had eaten all my new cucumber plants. And I was super annoyed by this because they take forever, right? And if you bite the top off, that's it, the plant dies. And so I want to know what it was, what got in, right? So I put a little camera out there I bought. And then I looked at the camera and how it worked and how the authentication flow worked. And because I am who I am and I do what I do, I realized that if you type in the wrong username, it would say error, bad username. And if you type in the wrong password, it would say error, bad password. What does that do for an attacker, right? I now can validate usernames and password lists very easily just by using the error messages. Which one is that of the three I said was going to be terrible for you? It's excessive data exposure, right? API 3. You don't want that to happen. So we're going to see this. We're looking for error messages. We want some information. You may see successes in here, but you're going to see a lot of failures. Login failure rate's going to float up, right? But usually in this phase where we're doing initial testing, we're not ready to really hit it hard yet because we're going to need to have better infrastructure. We're going to need to have good tools out there. We're going to have a lot of things in place in order to make this work, but it's going to be fast and it's going to be in the middle of the night, typically. Similarly, we see payment card enumeration, right? I find a gift card endpoint. If I can check a gift card and I don't have to do anything extra, if I don't have to be logged in to do it, if I don't need a PIN, right? If I can just type in a credit card number or a gift card number and see how much value's on it. I work with a small organization in Canada. They were having somebody check $250,000 a month off their cards, right? Now, lining that up with theft is pretty easy because I can say, well, somebody tried this gift card number and look, somebody used the gift card number. So put a pin on it. It's not that hard. Add a little bit to it. But then what's going to end up happening is, well, we'll just move to accounts, right? I'll do an account takeover and use online purchasing, gift cards that are available there, whatever that might be. Sometimes we'll do things like credit card guessing. My son has showed me this where he wants to buy some game, right? And he's like, well, Dad, I can just generate a credit card number and try it. And I'm like, don't do that, all right? I've been doing this for 24 years. The way that you do it for 24 years is you don't break the law, right? You can break the law and get rich one time, easy, right? A bunch of people do it. It's just when you want to repeat that and when you run out of money and stuff. So what we'll do is we'll try with what we call zero cost testing. I'll buy something from your website that costs $0 just to see if the credit card stuff will work, right? I can pre-generate Bamora tokens this way and a whole bunch of other things like that. So where are the IOCs in that? Well, zero cost transactions are rare, right? It's an easy one to find. So how are you going to figure out where all this stuff is? Because remember I said we got rid of all that client-side stuff and we got rid of the web apps, right? Everything's happening on the mobile app now. Well, we can tie up an IMEI number, we can do extra things. You need to work with your development staff to get that kind of stuff created, right? So that the app is actually feeding the system. But you're not going to be able to do this with your WAF, right? WAFs typically don't sit in line with API transactions, and they typically don't sit in a place where SSL is stripped off, or TLS. So what we end up seeing is a lot of instrumentation into some place, and that's usually Nginx or whatever that equivalent layer is for everybody else. If you don't know, this creates a whole huge pile of logs that you can go mine, but it also lets you do things like a Kafka pipeline, so you can have the logs flow through and then immediately make decisions on those things. This is exactly how my company's products work. I'm giving away all of our secrets here because this is how you have to do it, right? It's really not that hard. But what you want to try to do is create as much signal as possible so that you can do analytics on it. Data science is really important here. Doing things like just simple counts is also going to get you pretty far, right? Successes and failures, as I've talked about a few times. What are we doing? All right. Anybody hungry yet? It's almost lunch. We're close. The guy before lunch. So understand what endpoints are important to you, right? And this takes a little bit of analysis and a little bit of figuring, right? Is this endpoint important to me? Is this something that's going to have a data element that I care about? Login, sign in, authenticator, obvious, right? Cart, checkout, order, however your checkout flow works for your e-commerce site. But things like item availability, right? You're going to see more and more organizations that want to be friendly to their customers and create as little friction as possible. So if I need to go buy a hammer, I pull up my local hardware store website and I see, do they have the hammer? How many of you have done this type of activity, right? Everybody has these websites now. And I'm going to tell you a story about stopping theft at a brick and mortar through API IOCs. Really fun little thing here. But let's talk about the birth of data science. Let's talk about the birth of this analytics so we can understand how we can apply this, because those people that don't study history, something repeats itself. So in 1854, the very first data study was ever performed. It was performed by a guy named John Snow, who wanted to figure out why his neighbors were dying. At the time, cholera epidemic was spreading through London, but it seemed to be only in certain places. And they couldn't figure out what the thing was. Like, why are people dying from cholera, but only in these buildings? And so John pulled up a map, and he took a pen, probably one with a big quill on it, and colored in. Every time someone died, he'd color in that building. If you look at this map from where you're sitting right now, you'll probably identify there's a place where it's central, where everyone was dying. And you can see the big line here, and there's a lot of big lines around it. And you can look at the roads and say, well, the roads all seem to lead into the same place. And right up there by that longest bar, it says on this map, pump. Didn't have indoor plumbing in 1854. They had to go down to the fountain in the square or a pump somewhere nearby and carry that water home. And what John realized was this pump had cholera in it. Do you know what the solution to this problem was? They unbolted the handle. People couldn't pump water anymore, and people stopped dying, right? Using data analytics doesn't necessarily mean we have to do something really complicated. Right? I don't have to have a bunch of machine learning to figure out that we're seeing a lot of failures on the login flow, right? It helps you get there, but it doesn't necessarily need to be really complicated. So sifting through this noise, you're going to see things like behavior on user agents, right? I'm going to be Safari, Chrome, I'm going to be Edge, I'm going to be all these different things. Should they be on your API flows is the very first question you should ask. The second question is, should we see these old user agents, all this spread, right? You typically don't see that, especially with Chrome users, because that update button is annoying, right? You want to push it and get the update. And so you want to go through that. Monitor your top end, though. Look at what's out there and what is making the most noise. Headers, are you getting all of the headers? Because one of the first things I do is rip out auth headers. A lot of times, systems on the back end with no auth header present just assume that it's computer-to-computer communication and let me in, right? Oftentimes, 256As is a pretty good auth token, right? So look at these things, right? Canary headers. Put headers in that if they rip them out, you'll notice, right? They don't need to do anything, and you can just randomize them. But if they pull them out, send them into the honeypot, right? Let them go play in there for a while. Looking at rates is going to be important. So that's a behavioral indication stack. Well, let's move over to infrastructure. Can you tell what these two IP addresses, can you tell that they're part of some kind of attack flow? Whenever I look at attacks happening at my customer sites, I'll break it out into IP addresses like this as the data pivot, and you can just see it. 3,400 requests, 3,400 requests, 3,400 requests, 3,400 requests, 3,400. That's the machine doing that, right? That's not people. It would be very, I don't know, randomized if it was just people. So you have to look at how these things are going to show up in your systems. IPs versus username is a really great way to do this, right? How many of you use the same device for all the things that you do? Probably in your hand. I think someone just took a picture of me with it, right? So, cell phone. How many IP addresses is that thing gonna have this month? Probably 5, maybe 7. How many today? Maybe 2, maybe 3. If you see an end user showing up with 6 or 7 or 8 different IP addresses, that's probably an odd behavior. And it might be something that you'll want to look at. Username versus user agent. How many user agents do you have, right? I use Chrome pretty much all the time unless I'm attacking something. And then I use Firefox just because that's how I have my tool chain, right? And I also don't want to mess with sessions and stuff. That's just how I build it, right? User agents by population. Should we be seeing all these old user agents? Should we see all these different organizations out here? If you're a small company in Canada, should your users be coming from this wide of a spectrum, right? If you're here in Australia and you only deal with Australians and you never have to deal with anyone else, you probably shouldn't see traffic from Russia, right? Just block it right at the edge and get rid of it. Scanners are one of those things that we're seeing more and more of, simply because scanners make it easy to identify things. This is a big chunk of what Asset Note did with Kite Runner, but I've broken this down into what I'm seeing as actual successes, a lot of successes. And you can see in these endpoints what I'm looking for, right? Why am I looking for GraphQL so much? Anybody know? Because if I can find the GraphQL playground, on that playground is the database schema, how to make correct requests. It's like a attack path mapping, right? It's nice and easy for me to do. But there's a lot of other stuff that happens too. Subdomain enumeration. Look at your outside footprint. Do you have your staging sites or your dev sites just hanging off the internet and easy to get to? Maybe behind basic auth? We see this an awful lot. UAT sites and staging sites tend to have very interesting databases behind them because when a developer wants to create one of these things, they want it to work correctly, and so they want data that looks real. And you know where you can get a good copy of a database that looks real? Prod, right? There's a good database in there. It looks just like the one we need. Put that over in dev or UAT or whatever, right? So you have to look for people poking around on these things because they're trying to get to them, right? GraphQL on your UAT site, for instance, is a really nice attack path. So let's throw this all together. Customer comes to me and they say, we have a problem. We use a third-party API solution to help customers find things that they want. Now, the thing in this case, and in this story, is right here. Anybody know what this is? Guy with the hair said it's a hair dryer. I'm not, hair dryers aren't really a thing that I deal with a lot. It all fell out when I was 25. Anyway, what happened was they called and they said, we get 50,000 requests to this system that will tell people where they can find things a month. And on day 2 of the month, we're at 500,000. Something is going on, please help us, right? So we instrumented and we looked and we said, well, it turns out this is going to be a pretty easy problem to solve because they're only looking for 2 mailing codes, right? 2 zip codes, and they're only looking for 1 item, but they're really looking a lot. And so what we did was we worked with the organization and we said, go put 6 of these in your database in this store, right? So we saw the API behavior change when they did that. Now they were just banging on that store all day, right? They want to know, are you selling them? Are they selling out? Because the next thing they're going to do is run into the store, grab them, and run out of the store and not pay for them. And so this company dispatched the police. We cranked up the number of hair dryers available at this store. And sure enough, it was about 3 hours later, this team came running in. They grabbed the hair dryers and ran for the door. These hair dryers are $600, right? They're fairly spendy piece of equipment. And it's not because they have, an overly large amount of hair. They're putting them on eBay, right? They're reselling these things. So the police stopped them on the way out of the store and they arrested them. This is a sophisticated smash and grab robbery team using API endpoints to their advantage. Hype sales. The most confusing thing to me in the world is people that really want to buy these shoes. I don't understand it. So this is a time spread. I think this is 2100 and it goes to 0400. What happened? It turns out a bunch of people showed up, right? You guys heard about Taylor Swift and her Ticketmaster fiasco that's been going on lately? Very similar, right? All of these people showed up to buy the shoes. 3 minutes before the hype sale was to launch, this spike right here happens. We're creating carts. The way bots buy these things is they go buy or they add to their cart something no one wants that they have plenty of stock in. Kids' socks is usually what it is for hype sales on shoes because there'll be kids' socks that they sell. So then I put the kid's sock in a cart. What this is doing is I'm establishing the flow to check out, but I'm getting a step ahead of everyone that's trying to check out with me, right? So imagine this, if you will. I run into the store and grab a PS5 and go stand in front of the register, and you still have to run in the store. I'm going to get my PS5 first. So I add something in the cart that's innocuous, right? So now I have my checkout channel established. Then what I do is I start to look for the item that's going to drop, right? So in this case, Nike Dunks. So they don't release the item numbers ahead of time, right? They only go live when you say, search for Nike Dunks, search for Nike Dunks, search for Nike Dunks. Eventually they'll say, yeah, here it is, and here's the SKU. So now I have my cart built and I know the SKU. What's my next step? Update the cart with the new SKU and check out while you're still searching for Nike Dunks. This is how bots beat you, right? So what we do is we sit in this and we throw the traffic away. So all of this red traffic that came in and the white line there, 99.1% of the traffic on this particular sale we threw out so the humans could buy the stuff, right? So then they get really mad, the bot guys, they get mad, they threaten our researchers and all this. But they do this thing where they say, I couldn't cop any of these shoes today, but they usually have them pre-sold. If you go look at one of these hype sales, Supreme, Super Dry, it doesn't matter, right? You look at one of these really high volume items that somebody's wanting to buy, go look on eBay for it. They've already got it listed. They know they're going to buy it, right? They know they're going to succeed. The bots know that they're going to win. All right. 4 minutes left. I'm going to show you an example here of account takeover. If you look at just simply the ISPs that are touching a login endpoint, when it goes to bots that start attacking you, the ISPs are going to be inexpensive infrastructure. It's an immediate shift from what looks like normal in the United States. If I were to look at traffic on an e-commerce website that developed like this, AT&T, T-Mobile, Verizon, I would think this is all normal traffic. Cogent shows up? No, those are all bad infrastructure, right? Notice how easy it is to find the bots. It's just simply crunching the data science, crunching the numbers, looking at paths, applying a little bit of machine learning, and Viola, right? Easy enough, shut it all down. The IOCs that are sitting in your APIs are there for you to find. They're easy to find, and they're there for you to take action on. Does anybody have any questions? What happened to my cucumbers? That was a groundhog. I wrote a blog post about it, and I got a responsible disclosure out of it. So I built a little better fence and kept the groundhog out. So I work for a company that makes one of those. So obviously I'm going to say we got one. What you have to be able to do is tell Nginx to throw it out, right? You have to be able to do analysis in flight. So you're going to do a Kafka pipeline analysis and a mitigation flow inside of Nginx. It's going to be all hand scripted if you don't have the tools already built. We do it mostly in Python. Yep. Anybody else? Who's hungry? It's lunchtime, kids.